okay, it says that two minor arcs are congruent if and only if, okay, that makes it a biconditional, it's true both ways, if the chords are congruent. Okay? So you can kind of see it here, it's a little faint, but they did a little tick mark and a tick mark. So what they're saying is that chord AB is congruent to chord BC, and if the chords are congruent, then that means that these arcs are congruent to each other. Okay, so the blue is congruent to the green. And since it's a biconditional, it works the other way. If the arcs are congruent, the chords are congruent. So don't forget about that idea. Okay? So if they're congruent, how do we solve for x? Set them equal to each other. All right? What do you get for x? Anybody else? I got 137 out there. 37? 37? 37? 37. All right, so you should get x is equal to 37. Okay? All right? From there, okay, and this is, I'm going to add a bunch of different pieces on here. Okay, and it's going to talk about the idea that if a diameter is perpendicular to a chord, okay, then it bisects the chord. Okay, it bisects the chord. All right, so the reason we can tell that AB over here is a diameter is it passes through the center, so it has point C on there. Okay, and since it is perpendicular, okay, then that means tick, tick, these two parts are congruent. So that's what you're supposed to come up with. All right? Now, if one chord is a perpendicular bisector, that means it's perpendicular and it bisects, then it is the diameter. All right, so what I'm going to do is I'm going to just kind of add a couple of ideas over here. Okay, and so what you need to know is there's three things that you always are looking for, and as long as you have two of them, you can assume the third. Okay, so the three things are diameter, perpendicular, and bisect. Okay, so what I mean by that is if I give you a circle, okay, and I give you the chord is the diameter, and the way you can tell it's the diameter is it passes through the center, so it's going to pass through that dot. Okay, if it is perpendicular to a chord, then I can assume tick, tick. Okay, if I give you a circle and the line is again the diameter because it passes through the center, and it gives you tick, tick, then I can assume that it is perpendicular because I have two out of the three things. Okay? And so the second theorem here says that, hey, if I have a line and it doesn't give the dot for the center, but it intersects a chord and it's perpendicular and it bisects, well then this line has to be the diameter. So as long as you have two out of the three things, you can assume the third. If you only have one out of the three, you can't. Okay, and so that's basically what those theorems are talking about. Questions with that? Take a look at this example. It tells me that dB is equal to 12. Why am I given that information? What am I supposed to do? Divide it in 2. So DE is equal to 6 and EB is equal to 6. Then it says that FE is equal to 8. Okay, so I'm going to put an 8 there. Find the length of FB. Well, FB isn't even drawn, so I'm going to draw that in. How can I find the length of FB? Pythagorean theorem. Go. See what you get. So if you didn't get it, you should have had 6 squared plus 8 squared is equal to FB squared. This all adds up to be 100. Okay, take the square root, and FB equals 10. So it works. Okay? Page 2. All right, so similar concept. Okay, they just adding a couple of algebra skills in here. It starts out with the idea that DB is equal to 40. So what do we have to interpret from there? Knowing that AC is a diameter because it passes through the center and it's perpendicular to the chord. What are we supposed to interpret? Divide by 2. So this is 20 and this is 20. Okay? Then it says FE is 8 less than FB. So here's FB. Do I know what FB is? When you don't know what it is, what are you supposed to mark with it? X. Okay. Now it says FE over here is 8 less than FB. So how do I mark that? X minus 8. And then I'm back to a right triangle with 3 side lengths. Use the Pythagorean theorem. Okay, see what you get on this one. Okay, so let's set this up. We should have x minus 8 squared plus 20 squared equal to x squared. The key is you have to understand that the x is your hypotenuse. Are we good with that? All right. Foiling this out, you get x squared minus 16x plus 64. Are we good with that? Okay. 20 squared is 400 equal to x squared. Now, when I go to subtract this x squared to the other side, what happens?
Cancels out.
Cancels out. That's perfect. Now I'm down to a basic linear equation. All right? Now I have 0 equal to 16x, negative 16x, plus 464. How do I solve from here?
I just added 16x to both sides, and then I just divided by 16.
Okay? So 16x equals 464. Divide by 16, and she got x is equal to 29. Okay? Now, the answer is not 29. She said the answer is 50. Okay? Now, you asked, how are you supposed to figure out what the length of AF is? But we just figured out that FB is 29. So what's AF? 29. Why are they both 29? Radius of the circle, F is the center, okay? Now, if x is equal to 29, what's 29 minus 8? 21. So now our goal was to figure out the distance from A all the way to E. So what's 29 plus 21? 50. So AE is equal to 50. All right? The key to this, though, was you had to be able to come up with the 29. Do I need to go through that part again? Good on that? And we've been doing a lot of this, and we've been doing a lot of the foiling lately, okay? And again, that's why we did all that review before spring break, okay? All right, last theorem for the day, okay? It talks about 2 chords are congruent if and only if they are equidistant, the same distance away from the center of the circle, okay? All right, so I'm just going to kind of throw something in here. All right, if I were to have a circle, okay, and I were to draw 2 chords, are these 2 chords equal in length? No. One is obviously longer than the other, right? Okay, and the reason is they are different lengths away or different distances from the circle. Okay, if I were to add in on the other side of the circle, the same distance away, this chord, would you say that chord 1 is equal in length to chord 2? Yes. Why? Because the distance that they are away from the circle, the center of the circle, is the same. Okay? The further it gets away, the shorter the chord gets. So the distance from the center is the key. All right, so what does that have to do with our theorem? Well, it's basically saying here that if CG is equal to CH, which is what they tell us, then that means that KJ is equal to FE. If the distance from the center is the same, the chords are congruent. Now, let's add in the very first one that we talked about today. If the chords are congruent, what else is congruent? What else? Not angles, but a different A word with 3 letters. The arcs are the same. Remember the first one that we said that if the chords were congruent, then the arcs are congruent, right? We talked about that idea, okay? All right, so in the example here, they tell us that CG is equal to 4 and CH is equal to 4. They gave us that CE is equal to 5. My goal here is to figure out what HE is, because since it looks like CH is perpendicular to the chord, and since C here is the center, that means CH is part of the diameter. What do we know about FH and HE? They're congruent because it's being bisected. So can we figure out what HE is? Right? What's HE? Not 3.5. You shouldn't get a decimal. You should get a whole number. It's a Pythagorean triple. You should get 3. Okay? Do your x squared plus 4 squared equal to 5 squared. X squared plus 16 equals 25. Subtract the 16. You get 9. Take the square root. You get 3. All right, so if HE is 3, FH is 3. If both of them are 3, what's the entire length? 6. So what's the length of KJ?
6.
So there, we're done. KJ equals 6. All right? Again, big idea, if the distance away from the center is the same, the chords are the same, okay? All right, so in the next example, and this is where our trig is going to come into play, all right? In the figure below, same as before, CG is congruent to CH. KJ is equal to 7. Notice that it is perpendicular to the line coming out of the center. So what can you tell me about KG or JG? They're both 3.5 because they're half of 7, because it gets bisected. Which means that FH is also 3.5 and HE is 3.5. Okay? It says to find the measure of angle HCE. So our goal is to find this angle measure. How do we find an angle? Trig. Okay? So if you need to, I'm going to take this triangle, I'm going to kind of blow it up here. All right? We've got a right triangle, we've got a 3.5, we got a 5, and our objective is to find that angle. SOHCAHTOA. What are we going to use? So. Because this is your opposite, this is your hypotenuse. So sine of x is equal to 3.5 over 5. How do we solve for an angle measure? What do we use?
Oh, the opposite thing. Well, minus 1.
The minus 1 thing. That's called an inverse. So we're going to use the inverse sign. So we're going to say x is equal to sine inverse of 3.5 over 5. Make sure that on your calculators you're in degrees. So tell me what you get. $44. Anybody else? 44.4. 44.4. Are we going with 44, or you want to go with 44.4?
We go 44.5.
It's 0.42. The 2 would keep it a 4. So it's 44.4. All right. So we did the first thing. We figured out what the angle measure of HCE is. But it's asking us to find arc length FE. Well, we learned yesterday that the arc is equal to the central angle. So we need to figure out the angle FCE. Well, if this is 44.4, what's this angle next to it? 44.4. So what's the entire angle FCE? So then what's the arc length? Or arc measure, sorry? 88.8 degrees. Okay? So using a little trig to review, with our triangles. All right, so for today, okay?